Table 5 shows some observations from some test tube reactions of aqueous solutions of compounds Q, R and S with different aqueous reagents. And the colours of the compounds formed and whether the solids, precipitates, etc. are shown. So the observations, it doesn't tell you the initial colours of these. So let's have a little look. Barium chloride. Barium chloride is used to test for sulfates because it makes barium sulfate used in barium meals. So this is some kind of sulfate here. These two are not sulfates. Silver nitrate with nitric acid. That's used to test for chlorides, bromides and iodides. Silver chloride is a white precipitate, so R is something chloride. And a cream precipitate is a bromide, so Q is something bromide. So we've got something sulfate, something chloride and something bromide. A bromide, a chloride and a sulfate. Now let's have a look what happens with sodium hydroxide. I get a brown precipitate here, something hydroxide that's brown. So something that's brown, a coloured substance, is usually a transition metal. So I'm looking for a transition metal. A transition metal, a coloured solution that's brown. I know that iron hydroxide, iron 3 hydroxide, is a brown precipitate. So this is iron 3 sulfate. I'm just going to check here. A brown precipitate, bubbles of gas. Yes, iron 3, something that's charged 3 plus, is acidic. I'm going to give bubbles of gas with a carbonate, so that's correct. And a yellow solution, yeah, it's going to form FeCl4 minus as a transition metal complex ion. But I know it's a sulfate because it's given a white precipitate with barium chloride, which is used to test for sulfates. And I know a brown precipitate with sodium hydroxide will be FeH2O3OH3. And we'll see that in the second half of the question when we're asked to do equations, but it's iron 3 sulfate. Let's have a look what Q and R could be. We've got a white precipitate here, something hydroxide, so something formed the hydroxide, maybe something like magnesium. Magnesium carbonate would be a white precipitate as well. I think this is magnesium. I know that it's going to be something in group 2 because it's white. If it were a transition metal, it would be a coloured solution, and if it were in group 1, it's not going to form precipitate. So sodium compounds and potassium compounds in group 1 don't form precipitates. So I'm probably looking at something like magnesium bromide here. What's happening here? A white precipitate that dissolves in excess sodium hydroxide. You're looking at something like aluminium. Aluminium isn't a transition metal, and it also is aluminium is Al3 plus because it's in group 3, and that will be acidic and form white bubbles of carbon dioxide with a carbonate. So I think a white precipitate of aluminium hydroxide that dissolves in excess sodium hydroxide is aluminium. So I've got, let's just recap, I've got magnesium bromide, I've got aluminium chloride, and I've got iron 3 sulfate. Write the ionic equations for each of the positive observations with S. So that's iron 3 sulfate. So I'm looking for, first of all, barium sulfate to make barium sulfate. Now barium is in group 2, so it's going to be Ba2 plus. Sulfate is SO4 2 minus to form BaSO4. So it's BaSO4 because Ba is 2 plus, SO4 is 2 minus, and therefore it's just BaSO4. So that's my first equation. Ba2 plus plus SO4 2 minus forming BaSO4 as an ionic equation. Next one with no change observed here, so we're on to the brown precipitate. So we're on about Fe3 plus and 3OH minus ions, or FeH2O6 3 plus because it forms a complex ion. The 3 OH minus ions replacing the 3 ligands. I know that there's 3 in there, and I know that it's got no charge because that's a solid. It says it's a precipitate, and it'll make 3 waters released from the complex ions, releasing 3 of the H2Os. Next one is precipitate bubbles of a gas. So FeH2O 6 3+ is my complex iron 3 ion. Carbonate ions are CO3 2-. If you weren't sure of the 2-, look at the oxidation states. Oxygen is in group 6, so it forms 2- ions, oxidation state -2. And if I've got 3 of those, I've got oxidation state -6. Carbon's in +4, must be 2- left over. The carbonate ions are making the brown precipitate again, which is FeH2O 3OH3 iron 3 hydroxide, same as before. It'll make some water and it'll make some carbon dioxide as the bubbles of the gas. And then finally, my final one is concentrated hydrochloric acid. So concentrated hydrochloric acid can replace the water ligands to release 6H2O, but you can only get 4 Cls. They're quite large ligands, these, so you can't get more than 4 around. You can't get 6 as in water. You can only get 4 chloride ligands around a central metal ion, transition metal ion. I know it's -1 because I've got 4 Cl minuses. Cl is in group 7, so going to gain 1 electron and be Cl-. So I've got oxidation state -1. I've got 4 -1s. I've got Fe3+, iron 3, and 3 3+ and 4- leaves 1- left over, and it cancels. It works so it balances 1- on the right hand side with 3+ and 4 1-.